All right, so what we're going to do in this lesson is begin to analyze graphs of functions. And largely what we're going to be working on here is figuring out what is the domain of a function, what is the range of a function if we can see it, and we're going to be determining if it's a function or not. We're also going to introduce the average rate of change formula, which many of you are familiar with. We're going to practice using that in class. So what we're going to start with here is two functions that we can see, and we need to determine what the domain and the range are of these two functions. So let's just call this first function f, and we'll call this other function g, and we can see them. So it should be pretty easy for us to determine what the domain and the range are of these two functions. Remember that domain is your input values, usually your x values, and range is your output, usually your y values. So what we're doing here when we're saying what is the domain of the function is we're saying, what am I allowed to plug into this function? And I could give you an example of a number I'm not allowed to plug into this function. I am not allowed to plug in -1 into this function, because you'll notice that if I go to -1 on the x-axis, there is no place that the function exists if my x value is -1. So -1 is definitely not in the domain of this function f of x. All right, so when I'm outlining the domain, I can't say that it's all of my numbers. Well, if I go from the negative x direction to the positive x direction, it looks like the first number I'm allowed to plug into the function is 0. So I'm going to start with 0. And I can plug in 0, so I'm going to say 0 is less than or equal to my x values that I'm allowed to plug in. And when am I not allowed to plug in numbers anymore? Well, 0 is fine. 1, 2, 3, 4, 5. I've got outputs all along this function. 6, 7, all the way up to 7. But you notice, even if it were 7.1, I would not be allowed to plug it in. So 7 is where this ends. So I'm allowed to plug in any x value that's between 0 and 7. And another way to write this would be closed bracket 0, 7, closed bracket. Both are totally acceptable ways to write that. Now let's talk about range. What are my outputs? Well, I could give you an example of an output that is not attainable with this function. 5. So 1, 2, 3, 4, 5. There is no way that I can get an output of 5 with this function. So 5 is not in the range of my function. What values are in my range? Well, the lowest value this function ever reaches is -2, right? That's the smallest value that my function reaches. So -2 is less than or equal to my y values, is less than or equal to, what is the largest value the function ever reaches? Well, it does go up to 4, but it never goes beyond 4, so is less than or equal to 4. And another way to write that would be closed bracket 2, 4. And the reason we're using closed bracket instead of parentheses is because our function does exist at 4 and at -2. It's not like it's just getting really, really close and then never actually reaching that value. All right. Now with our second function, g, we're going to make an adjustment to g of x, and I'm going to actually put a hole in the graph right there. So what I'm doing by putting the hole there is I'm saying the function does not exist at that point. It gets very close to it, but never actually reaches that point. And over here, I'm going to put an arrow. So I'd like you to do the same thing. All right, so what's the domain of this function? Well, this function does exist at 0, at -1, at -2, and it gets really close to existing at -3, but it never actually exists at -3. So what I'm going to do when describing the domain is I'm going to say that -3 is less than x. I'm not going to say or equal to, because I can't actually say that the function exists at -3. All right? And then in the other direction, I could go to 1, 2, 3, and this arrow is showing me I could go forever in the other direction. So I'm going to say is less than infinity. And the reason I'm not going to say or equal to infinity is because infinity is not a number, so I can never actually reach infinity. The other way to write this would be open bracket -3, infinity. Now when I talk about the range, I'm talking about potential output values. So what is the lowest potential output value? Well, it looks like it's -2, but it's not. Because remember, our function never actually reaches this point. It's just really, really close to -2. So I'm going to say that -2 is less than y is less than, and what is the maximum value my function reaches? Well, it looks like it goes up forever and ever and ever in this direction, so it will continue to go upward. I'm not going to specify that I know exactly where this thing levels off if it does, so I'm going to say that it goes towards infinity. So another way to write that would be open bracket -2, infinity, parentheses. All right, so now let's talk about the second part of this question, which says, classify these as either functions or non-functions. Well, we have a way that we can determine if we're dealing with a function or a non-function, and you all know probably what it is already, but we're going to define it here. It's called the vertical line test. All right, so this is a definition you should record. If you can draw a vertical line that intersects with the graph 2 or more times, the graph is not a function. So I'm going to use a blue line here. With our f of x function, I could draw vertical lines all day long, and no matter where I put them, there's no way that I could draw a vertical line that would hit my graph of f of x more than one time. I would even get some that hit 0 times. That's fine. But I can't draw a vertical line that intersects with our graph twice. So f of x is a function. G of x, however, is not the same. Right here, if I draw a vertical line, I only hit the function once, or the graph once. Here, again, I only hit it once. There are other places where if I draw a vertical line, I only hit the graph one time. But because there are some places where I will hit the graph 2 or 3 times, already, because this happened with a vertical line, I can say that g of x is not a function. And the vertical line test is a way to figure that out by seeing the function. And what it's showing us is it's just saying, if it fails this test, then what that means is when I plug in these input values, I don't know what my output values will be, so it's unreliable. And if it's unreliable, then it's not a function. Because in this case, g of x, if I plug in a 0, what will my output be? Well, maybe it'll be -0.1 or whatever that is. Maybe it'll be positive 1.5. Maybe it'll be negative 1.4. I don't know. I do know that if I plug in a 2, it looks like I get an output of around 2. That I can count on. But there are some inputs that I can't count on, so it's not a function. All right? So the vertical line test is how we can figure that out when it's graphed. Now, what I'm going to introduce you to that you're probably already familiar with is the average rate of change formula, and then we're going to use it in class. So, for a function f of x given below, determine the average rate of change of f of x over the interval from -2 to 0. Again, another way to write this would be -2, 0, close brackets. Okay? What we're going to do is write down the average rate of change formula, and then we'll apply it here. All right? B and A, they just represent the smallest value and the largest value of x. So in this case, from -2 to 0, -2 would be my A, 0 would be my B. It doesn't matter which is which. Again, kind of like when we're determining the slope of a line or using the distance formula. It doesn't matter what order, as long as you're consistent. So if I apply this formula here, I'm going to have f of 0 minus f of -2 all divided by 0 minus -2. And so in order to do this, I actually have to figure out what is f of 0 and what is f of -2. So off to the side, I'll do that calculation here. F of 0 is going to be 0 to the third minus 3 times 0. And so that ends up giving me 0 minus 0, which is 0. All right, f of -2 is equal to -2 to the third minus 3 times -2. -2 to the third is -8, and this would end up being +6, so that gives me an output of -2. All right, so I determined that f of 0 is 0 minus -2 all over 0 minus -2. You can see where this is going. I end up with a +2 over a +2, or 1. So in this case, the average rate of change is 1. And what that's saying is that if you graph this function, this cubic function, the average slope between that point, those 2 points, is 1. And you can go ahead and try to do the second part of this. You can do this, and we'll get to it in class, and then we're going to do a bunch of practice with this. All right? So make sure you've got the formula down and give this a shot before you come in tomorrow.